All right, good morning, guys. This is a video on parametric equations, which is a brand new lesson. You're going to need to take out a sheet of paper or print the notes that say 7.5. They're attached in the classroom. You're going to need your graphing calculator or an app that will do this. And I will do my best to show you how that would work. It is possible to do all these questions with just a scientific calculator as well. All right, the app, if you want it, it was posted here in Google Classroom. That's what it looks like, okay? Our learning targets are to be able to graph parametric equations and switch them into rectangular form. We eliminated a lot of the tricky ones. We're going to stick with the basics. Most everything today is going to be either a line or a parabola. The projectile motion I'm going to do in a separate video. Right, this is just real quick what a parametric equation is or why we do them. This is a population over a course of years of wolves and the population of rabbits in the same habitat. Now, if we were to graph those where we did, for each input, we determined the number of rabbits and the number of wolves at a certain amount of time. So this is wolves across the bottom, rabbits here. You'll see that it's cyclical. As the number of wolves increases, the number of rabbits decreases, and so on. So it's a way of combining two things in terms of a third variable. So an example we have used is we have graphed the vertical distance something goes up, its height at a function of time, and it turned out to be a parabola, but the object was really just going straight up and straight down. Okay, if we were to graph its horizontal distance when we threw a basketball at the net or whatever, its horizontal distance away from us would just go up. It would get further away. If we, though, graph vertical distance and horizontal distance as a function of time, we can see the height and distance from us at each point in time. That's the idea of a parametric equation. So it says the variable t is called the parameter. We now determine where an object was by evaluating the horizontal and vertical components for t. The graph shown is plotted over the time interval from 0 to 4 seconds. We're going to have to set an interval for our t value, both in the calculator, and it's going to help us determine endpoints. Plotting points in the order of increasing values from 0 to 4 gives this shape, and there's little arrowheads on here. We can determine orientation. Now, in the lesson, in the quizzes that goes with this, there's not a lot of focus on orientation. If we were teaching this in the classroom, we'd worry a little bit more about that. You want to put your calculator in parametric mode and in degrees. Degrees doesn't matter for today's part. For the second lesson, it will matter. So while you're in there, make sure you're in degrees and then switch from function to parametric mode. I'm going to do that real quick on this one. Mode, arrow down, arrow to the right, hit enter, arrow down, arrow to the right, hit enter. Now, what happens when you do this is when I hit this X key right next to alpha now, that I'm in parametric mode, I get a T, not an X. That's going to be really important because when I go here, I'm going to want to get a T. We'll get to that in a second. Sorry, my dog has decided he's very thirsty while I'm trying to record this. Okay. So this one we're going to do by hand real fast, or I'm going to do. It says sketch the curve given by this parametric equation. And it says for the values from -4 to +4 for t. So I made a little chart from -4 to +4, there's my t values. Then I put those values of t in to solve for this x. So I squared them all and added 5. -4 squared is 16, added 5 is 21, and so on. Then for the y values, I went back to the t. Be very careful you don't use the x. And I put this t value in. So -4 divided by 2 is -2, plus 4 is 2. -3 into here and here gave me this ordered pair. Then I plot these xy ordered pairs. So the t values were actually plugged into the rules to develop the ordered pairs. And then I plot the ordered pairs. They started over here and they wound up over here when you plot them in order, 21, 2, etc. And so we can indicate orientation with these. Now, what do you notice about this? Is this a function? No, we can plot things that are not functions, and we get endpoints. The -4 and 4 indicated this was an endpoint, and this, because those were the two end values for t. Okay, so the idea is that a parametric equation can help us graph things that are not functions. We're not going to spend a lot of time on some of the really cool, crazy ones because we're not going to do polars this year. But we're going to try this example that you should have on the notes. And I'm going to try to do it by hand, but I want to go kind of quickly here. It says, for the rule to find this, you're going to take the t, multiply it by 4, and then subtract 3. I'm just rewriting this in a little bit different form. So I'd get -12 minus 3 more would be -15. -2 times 4 is -8. Minus 3 more is -11. -4 minus 3 is -7. 4 times 0 minus 3. 4 times 1 minus 3. 4 times 2 minus 3. Let's see, that would be 12 minus 3 and 16 minus 3. All right, I think I did those all right. Then if I go back up here, remember I'm not using the x values. I'm using these t values again to go over here and plug in this rule. I'm supposed to square them and add 3. So that would become +9 when I squared it, and 3 would be 12. 4 plus 3 would be 7. 1 plus 3, 0 plus 3, 1 plus 3, 4 plus 3, 9 plus 3, and 16 plus 3. Okay. By the way, I skipped this, and it was very important. It says, sketch the curve for this parametric over the interval. They will always tell you what you need to put for t here. So it said from -3 to 4. It can be any values between -3 and 4. It could be decimals, fractions, but I'm just going to stick with the integer values so that I can plot this. Then when I go to plot them, I am plotting these points, -15, 12. All right, this is going to be a really bad sketch because I can't read this graph paper, so I'm going to use the Hofbauer big blob theorem. -11, 7, somewhere in here, -7, 4, -3, 3, +1, 4, +5, 7, 9, 12, and 13, 19. I'm sure these are not accurate, so just, okay. So it did go this way if we want to indicate orientation. It started here, and that was the end point -15, 12, and that corresponded to the t value of -3. And then we ended up at 13, 19, and that corresponded to the t value of +4. All right, so this, I shouldn't have made this arrowhead be so far out here, I guess, because it looks like it's on the end and it's not. it ended at 13, 19. I don't know if that's right, but it does end, okay? It does not continue if you are only talking about the values between -3 and 4. All right, the arrowheads are simply orientation. So that's a parametric, graphing a parametric function. All right. The other part of the lesson today is switching this from this form into rectangular form, or a form that only has x's and y's again. So what we're going to do is solve, and I usually look if there's one that's linear. Sometimes they're both linear, but this one is linear, meaning it doesn't have a squared. So I'm going to solve this one for t, which would make x divided by -3 equal to t. And then I'm going to plug that in this guy for the t. So it will say y equals x over -3 squared plus 2, which when I square that, I get x squared over 9 plus 2. Or they wrote it here as 1/9 x squared plus 2. All right, we're going to do, what do we have next? Okay, that's called eliminating a parameter. It says in general, solve the linear one for t and then substitute into the other one. And again, there are great applications using conics and trig, but we just cut some of those. So it's going to be a little boring today, just some quadratics and some lines. So example 2 you have on the notes sheet. This one is linear, this one is quadratic. So I'm going to go ahead and solve here for the value for t. So I would add the 2 over and then divide both sides by 4. And then now that I have t by itself, I can substitute that in here and get y equals x plus 2 over 4 quantity squared plus 1. And it would be okay with us if you left it that way. I will tell you that a lot of times they would square this top and bottom, and remember, x plus 2 quantity squared does not become x squared plus 4. There would be another term in there, so just leave it. Square the denominator becomes a 16. And so a lot of times we would write it in vertex form as a is 1/16 x plus 2 quantity squared plus 1. Okay, so any of these three are okay with us. All right. Now write example 1 in rectangular form. So this is, go back on your notes, we're going to rewrite this first one we did. So we add 3 over here. Divide by 4. Why do I feel like this is the same question? Oh, it's not quite, I guess. Now we have t, equals this. I guess that's not going to print out very well in the notes. Let me rewrite that. And I'm going to substitute that in here, and I'm going to be real lazy and just leave it. This plus 3 goes on the back. All right, moving on. One more where we're going to graph. It does, on your paper, it has these numbered by 2s, so it counts this as 4, 8, and so on. But this graph doesn't need that much room, so can you renumber these by 1s on your notes if you printed them? So this is going to be 1, 2, 3, etc. All right, so it says for the values from -4 to 4. So if you didn't have a table, which there may be one isn't on your notes, I can't remember, I would create a table that just said from -4 to 4. Now that's a lot of values. We could actually skip a few if we wanted. And I'm going to show you how to do this on your calculator in a second anyway. But I'm going to put those values in here to get my x values. I'm supposed to square them and add 4 this time for the x's. So square this is 16 plus 4 more would be 20. 9 plus 4 is 13. Square this is 4 plus 4 is 8. 1 plus 4 is 5, 4, 5, 8, 3 squared is 9, plus 4 is 13. Make sure this is making sense. Okay, then I'm going to go and put the y rule. I'm supposed to take half. That could be tricky. And then subtract 3. I'm going to get some decimals this time, because remember, I'm putting these values in here. So negative 4 divided by 2 is negative 2, minus 3 would be negative 5. This one's going to be a decimal. Negative 3 divided by 2 minus 3 is negative 4.5. Now negative 2 divided by 2 is negative 1, minus 3 would be negative 4. I'm just going to write the rest of these down real fast. All right, so then I'm supposed to plot them, but I actually can tell the endpoints already because this was defined as negative 4 to 4. So this is an endpoint, and this is an endpoint here. All right, but I want to plot them in order so that I can see the orientation of the graph. If I go over 20 and down 5, I go over 13. These are counting by 2s going across here. And down 4.5. If I go over 8 and down 4, 5 and down 3.5, over 4 and down 3, over 5 and down 2.5. I'm starting back around here. My parabola shape is going, whoa, this way. All right, where did I leave off? 8, negative 2, 13, negative 1.5, and 20, negative 1. All right, and again, it stops here. This is an endpoint. The arrowheads are indicating orientation. All right, so that is a non-function that has graphed with parametrics. All right, now we're going to try to figure this out on the calculator. So what I want you to do is go to your y equals, go to y equals. Okay, I'm going to go over the one more time. Make sure your mode is in degrees, and then down here in parametric, not function. Because then when you go to y equals, you should see this notation, x sub 1 of t, y sub 1 in terms of t. And make sure none of your plots are on, because we were doing stats last. If those plots are on, it'll mess you up. So if those happen to be darkened, just go up and hit enter. Okay, if it looks like that, go up, enter, down, so none of them have black boxes around. All right, I have something in here that is for a different problem, I guess. Okay, up here, I'm going to put t divided by 2. And for y, the rule is square root of t plus 2. Oh, nice. This one's going to mess you up if you don't get out of the box. So you got to do square root t, then arrow to the right. And was it plus 2 or plus 3? Plus 2. Okay. Make sure this is not all in the same box underneath the square root. If it's all under the square root, you'll get different answers than I'm going to get here. All right. Then a huge part of parametric graphing on the calculator is setting the window, because this is where you tell it what t values to use. So this question says, I want to use t's from 0 to 9. So when I'm graphing, or when I'm setting the window here, I need it to say from 0 for the t minimum to 9 for the t maximum. And this t step is a problem for students. Just use 0.1. I'm just going to tell you, we're just going to always use 0.1. If we were doing other kinds, we could show you what happens and all kinds of crazy business, but a t step of 1, I could show you 1 in a minute, but you want it to calculate a lot of values. So this is going to calculate 10 values from 0 to 9 and then connect them with a smooth curve. If you set the t-step at like 5, it would calculate 0, 5, and that's it. You want it to calculate a value and connect it all the way along from 0 to 9. And this is going to put in 0.1, 0.2, 0.3, etc. All right, then for the X and Y window, I think you could probably just do a zoom standard. I looked at the graph paper and said, I'm just going to put -5 to 10 and -5 to 10 because that looked like what the graph paper was there. Okay, -5 to 10 by 1s, -5 to 10 by 1s. You could do -10 to 10 and -10 to 10 and it would fit. All right. The next thing we're going to do then, we've had that all set up, is just hit graph. Okay, we're going to get this little tiny graph, piece of a parabola, or it looks like a square root graph almost. And if I hit trace, I could see the ordered pairs down here. Now, as I trace to the right, it is tracing by tenths because that's what my t-step is set up as. Okay, but I can also go second graph. As long as in second window, it's set up as auto, okay? And you want to count by 1s here probably. Then if you go second graph, and we were supposed to do 0 to 9. Notice it will calculate other things, but it says there's an error because we told it to start at 0. All right. And go to 9. So there's the values we're supposed to plot. Notice because of the square root, they're really ugly. So I have them down here. I'm going to try to plot them real fast. Remember, we're plotting these as ordered pairs. We're not plotting the t values. So over 0 and up 2, over 1/2 and up 3, over 1 and up 3.4, 1 1/2, 3.7, 2, 4, 2 1/2, 3, 3 1/2, 4, 4 1/2. It finally hit 5. And that's actually where we stopped because we were supposed to only go to 9. All right, so there's the graph and there's the orientation. All right, and the endpoints were at 0, 2 for 0. And when we put in a 9, we get out 4.55. All right, if you need to go back through that part of the video because you're trying to do the calculator thing, just pause it and rewind that little section. But I'm going to keep going here. All right. By the way, this is not worksheet 13 this year, but we're going to solve either one for the other. It does say y equals down here, so I think I'm going to solve this one. It would become x minus 3 equals 2t, and then if I divide both sides by 2, I have t equals x minus 3 over 2. Then if I put that in here, I'd have y equals x minus 3 divided by 2, and it has a minus 4. Now, since there's no squared, I can actually simplify this one. If both of those are over 2, it would look like that. 1/2 x and 3/2. And then if I combine these, I'd have 1/2 x minus 3/2 minus 8/2. I'm just doing that in my head. It would look like that. Or you could give it a decimal, doesn't matter. But it is a line. It would be a line. It would actually be a line segment if you were to assign restrictions on t. All right. This graph has a squared over here, so I really don't want to deal with that. If you solved this, when you divided, you'd have to remember to square root and put a plus or minus, so it gets nasty. So if we just solve this one for the t, would just be x minus 5 equals t. Then we can put that in here, and we'd have y equals -3 times x minus 5 squared. And I would just leave it like that because that is vertex form. So I would just leave it. I wouldn't bother to, FOIL it out or anything. Okay. Last example of this, just so you get one more practice with the calculator. I'm going to go back to the calculator and go to y equals. And I am going to put in t squared minus 1 for x. So I go up here. And remember this, I don't know if I made a big deal about that, but to get the t now, you're using this x button. T squared minus 1. Whoa. Okay. Then if I go down here, the y rule is 2t plus 5. 2t plus 5. All right. You get all that typed in, make sure it looks good and that this is a minus and everything. Then you want to go to the window because we have to change our window. This time it says the t restriction is -3 to +1. So if you were doing this without a calculator, you'd put -3, -2, -1, 0, 1. And then you would square them and subtract 1 to get this rule. And over here you would double them and add 5 and plug those values in here. But I'm going to use a calculator. All right, back to the calculator, which I have lost. So my t window was supposed to be -3 to 1. So I'm going to change this min and max to -3 to 1. Always leave this 0.1. And this graph paper actually goes like -10 to 10 and -10 to 10. So if I want my screen to resemble that, I can change that here. Right. Then if I go to graph, this is the shape I'm going to get. If I want to trace to find ordered pairs, I can. This is weird though, guys. Look, I cannot trace left and right. Okay? As I say trace to the right, it actually moves to the left. That's because the only thing you can do is move backwards and forwards in terms of those t values you assigned. The leftmost t value, or the least value of t, not left, is -3. So it's going to start wherever that point is, and then as I arrow to the right, it's moving in increasing values of t till we get to 0 and then 1. Okay, and then it won't let me go any further to the right, and I can just go back in terms of time. Kind of cool. All right, moving down, or what I'm going to actually do is go second graph. Here's the table, so I can put those values in over here real fast so that I can plot them. And I actually have them down here. All right, I had, oh, I don't know what I just started to write down there. Did I do it backwards? No. Okay, 8, 1, 3, -1, 0, 3, -1, 5, and 0, 7. All right, if I scroll back up here. So let me make sure that those are right. I was supposed to square it. Yeah, those look good. So 8, 1 was one of the endpoints. And this is where it's important you would write this down. From -3 to 1 was what I used for t. And I counted by 0.1s. I used -10 to 10 and -10 to 10 for those. And then at 1, the other endpoint is going to be at 0, 7. All right. I plotted 8, 1, 3, -1, 0, 3, what am I doing? -1, 5, and 0, 7. What did I do wrong? Oh, because this one was a, oh, this is a -1 and this is a +1. Good Lord, I had a disaster. Well, it's not worth recording the whole video over. I'll just fix it here. All right, so it should have been 8, -1, and 3, +1. That looks a little better. And again, it started over here and it was moving this way. My arrows are terrible. So there's the orientation. All right, and then one more time, practicing eliminating t. Let me move this down so we can, well, I will in a minute. I had x equals t squared minus 1, so I don't really want to mess with that, but y equals 2t plus 5. So if I subtract 5 and then divide by 2, I would have t all by itself, and then I could put this in here. Why, can anybody tell me why it makes sense that I would get a y minus 5 squared? Well, the answer is it's a sideways parabola, so it should have the y squared and not the x. All right, before I turn this video off, two things. I want to move this down, and I'm going to get this in the conic form just because some of you will remember this form. If I add the 1 over to the other side, square the top. If I squared this 2 on the bottom, I'd have over 4, or I could write it as a 1/4. And if I multiplied both sides by 4 to get rid of the 1/4 here, I think this is the, whoops, sorry, that I can't remember all of a sudden, but I'm pretty sure that the 4p went on the side without the squared, right? Okay, so that's the conic form that we were using when we did parabolas in chapter 7. But either way, all right. So the first part of the assignment, actually, before you try to do the assignment, you should probably watch the second video on the applications. Otherwise, you can do parts of the worksheet, but skip the applications until you've watched the other video. Thanks, guys.